Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at a library of console alerts. In this series of videos I'll be covering the creation and use of libraries. So you might ask, why use libraries? Why not just write code whenever you need it? Well, if you're writing a lot of applications, having common libraries that contain functionality that you use often will save you time, both coding and testing. It will also make your code more readable and therefore maintainable, which is always a good thing. In the development work I do in PowerBasic, I probably write many more console applications than I do Windows applications. In the Windows compiler, you do have the message box function and statement. The message box function and statement is quite useful to allow you to put something on the screen to let you know where you are in the code. This is handy during the debugging of your application to save you having to go all the way into the full debugger utility. However, if you're programming in the console compiler, you don't have that facility. However, there may be times, both in testing and production runs, where you wish to alert an operator that something untoward has happened. So how can we achieve this in the console compiler? Well, today we're going to create a new library called Console Alerts. And we're going to create 3 new functions within that library to give us some options. So we've added an include at the beginning of our application to bring in our new library. The new library at the moment is quite empty, but we're going to create some new functions for it. Now, since this library could be used by either the console compiler or the Windows compiler, anything we put into this library specifically for the console compiler will need to be coded up appropriately so that it won't fail when you try to compile it in the Windows compiler. So the first thing we'll do is to put in a routine to put a message onto the standard console in a different color and wait for the user to press a key to continue. So we can create a conditional compilation by use of this construct. With this line in the code, anything inside the if and end if will be compiled only if you're compiling within the console compiler. If you're compiling within the Windows compiler, this section of code will be ignored. So the function we're going to create is one to wait on the console for the user to press something. So this new function is going to accept a single parameter, being the text you wish to display on the console. It will then wait for the user to press a key on the keyboard before continuing. This is a very simple function. All we're doing is we are changing the color of the console. So the foreground color becomes 4, which is red. We're printing the text we've been given onto the console, and then a message to say press any key to continue. We're using the wait key statement to wait until the user presses a key on the keyboard. Then we're turning the color back to green and we're exiting the function. So if we go back to our main piece of code and we put a call to this in. Any text you have in here is what's going to appear on the screen. So if we try running that now, we'll see the message has been displayed on the screen and it's now waiting for me to press a key on the keyboard before continuing. So that's a very simple, straightforward message on the console. It is possible in the console compiler to have an application which has no console. Therefore, there will be nothing for the user or operator to actually see on screen. One option we could use in that is to use the speech API library we have already created. Putting an entry at the beginning of our code to encode this library allows us to use the functions within that library to allow the machine to speak. A simple call to the fun speak with the text you wish to have. If we run that now,
the system has failed as the file cannot be loaded.
And once the speech is actually finished, the program will continue. However, another option which gives us a bit more flexibility is to use a graphics window. So how can we create a graphics window and put our text on the screen? Well, in our library we're going to create a new function called FunGraphicAlert. This will take two parameters, the second parameter being optional. The first parameter will be the text you wish to display on the graphics window. And the idea behind this graphic alert is that it will display on screen for a set number of seconds and then it will disappear automatically. I'm going to set it to default to waiting for 5 seconds and then continue. However, if you specify an optional number of seconds to wait, it will change to that length of time. Using an optional parameter means you can actually test to see whether that parameter has been given or not. So we can use the isMissing function for that to work out whether our optional parameter has been specified. If it has not been specified, then we default to waiting for 5 seconds, which is 5,000 milliseconds. If the parameter has been given, we will take that number of seconds and multiply it by 1,000 to turn it into milliseconds. Now, since we're going to create a graphic window, we'll want to set a font on that window so it's of a reasonable size so the user can actually see it. So we will first create a new font. So we're setting a 24-point font in bold, and we're passing that to a variable which is a handle for the font. Now we will create a graphics window and attach it. You can vary the size of this window depending on what you actually need. And having created a graphics window, we want to set the font, and in this case we will turn on word wrap, so that if the text given is too wide for the graphics window, it will fold down to the next line. And there may be a possibility in this case that the user is going to give us a piece of text with embedded carriage return line feeds. So a simple for next loop will allow us to print each of those individual lines without problem. Using the parse count to work out how many carriage return line feeds there are, and printing each of those individually onto the screen. All we need to do now is to wait for the specified number of seconds. This will either be 5 seconds or the number the user has specified when they called the function. And at the end we can close down the graphics window and end the font. So if we try using that in our application, we can send a message onto the graphics window. And there is our message. It will wait for the specified number of seconds and then will terminate. Now in this case we didn't actually specify the number of seconds, therefore it waited for 5 seconds. If we only wanted to wait for 1 second, we can change that by putting in the optional parameter. And the message will disappear much quicker. That's fine for a short message to the screen which only sits there for a few seconds. However, the user may not be watching the screen all the time. So we may want another alert message where the user will have to click something on the screen before the program can continue. So we'll create a very similar function called graphic alert with wait. This function is going to be very similar. However, it only has one parameter and no optional parameters. The single parameter is the text you wish to display on the screen. Now I'm going to use two fonts in this, one slightly larger than the other. This will allow us to display the text the user wants on the screen in a large font and a message to say press any key to continue in a smaller font. So we'll create our graphics window as before, and we will set the font and turn on word wrap. And as we did earlier, we will actually loop around the text message looking for carriage return line feeds and print each one out individually to the graphic window. So this piece of code is almost identical to the previous function. So the only difference here is we want for the user to press a key on the keyboard or to close the graphics window itself. So how do we detect when the user has actually closed a graphics window? Well, the first thing we'll do is we will capture the handle of the graphics window. And we'll save that into a variable called HDC. And we will also attempt to trap any key on the keyboard, also into a variable. And we will use a while loop to wait until the user actually does something. So we will continue in this loop while the value in this variable is blank. In other words, the user has not pressed a button on the keyboard. And also where the value in this variable, the handle, is not 0, which means that the graphics window is still open. We will have a short sleep, and then we will trap the key being pressed, if there is one, and also the handle of the graphics window. So when we drop out of this while loop, we can then close the graphics window and end the fonts, and return control to the main program. So let's try that in the main code. So a call to fun graphic alert with wait, with the text message, in this case with a carriage return line feed in the middle. If we try running that now, our code will display a graphics window on the screen, with the text provided. It will then wait indefinitely for the user to do something. If we press a key on the keyboard, we will return to the main program. If we try that again, and this time rather than pressing a key on the keyboard, we just close the window down, then it returns to the main program. So this gives you a nice mechanism by which you can actually display information to the user, wait for them to do something, and then continue. So what we've looked at today is a few mechanisms by which you can actually let the user know within a console window that something has occurred. But that's it for today. Thank you for watching.